In this presentation we will compare electricity production by combustion of rapeseed in CHP with combustion of chicken manure in CHP. Findings are based on analysis using the tool LCA, data from scientific publications, and lecture input. Before comparing the two processes in terms of global warming potential and the relative contributions of the different processes, a detailed account will be given of the implementation of the new biomass energy conversion chain, including chicken production, manure transportation, storage and drying, and combustion. Allocation was applied to the latter process due to the fact that both heat and electricity are produced. Since chicken production has revealed to result in significant greenhouse gas emissions, we compared two process chains, one in which manure is considered as a waste, and one in which manure is considered as a good. For the latter option, we calculated that 385 kg CO2 equivalents are related to the production of 1000 kg of manure. At the upper part of the screen, you can see the chain for electricity production from chicken manure, and at the lower part of the screen, you can see the chain for rapeseed. We calculated the amount of chickens that are needed in order to produce 1000 kg of manure a year. We then calculated the amount of CO2 equivalents per kilogram of product. But only part of the total global warming potential for chicken production can be attributed to the amount of manure we use as an input for energy production. We assume this part is 0.5% of the global warming potential. Yet, 0.5% already makes a significant contribution to the global warming potential, about 382 kg CO2 equivalents, inserted as an extension. In the alternative, chicken manure is considered as a waste product, so the process of chicken production and related emissions are removed from the chain. Data for the transportation of wet chicken manure were given. Emissions per lorry are assumed to be the same as for rapeseed. Emissions from lorry include CO2, N2O, waste heat, and methane. Emissions during storage are 3.1 kg methane and 0.014 kg dinitrogen oxide. Electricity for storage can be neglected. Products going into the drying process are stored chicken manure, almost 1000 kilograms, and 340 megajoules of heat from the heat pump driven by heat from combustion of chicken manure in CHP on site. This will compensate for the lower energy value of the waste heat. The products going out of this process are emissions, 1 kilogram of methane, also 830 kilogram manure with dry matter content of 60% is going out.
We calculated that the dried manure has an energy content of approximately 9000 megajoules. It is combusted with an electric efficiency of 42%. This way, little over 1000 kilowatt-hour electricity is produced. The remaining energy, little over 5000 megajoules, is thermal and partially used for drying the manure. Despite transportation losses, the amount of heat produced will be more than enough to substitute the heat that was originally produced from natural gas in an industrial furnace. We assume that no significant energy inputs are needed to start the process. Allocation is partitioning. We assume about 15% losses. As for the emissions, we assume full combustion. That means that 50% of the dry matter content is converted into CO2, which is about 250 kilograms of CO2. This needs to be allocated, since there are two processes to which the emissions are attributed: heat and electricity generation by CHP plant. We decided to apply partitioning to calculate the relative contribution of each process to emissions. For transportation to the consumer, there is a 4% loss. These are the results of our LCA. Aggregating inventory data in understandable impact categories, we choose for the impact category climate change with global warming potential as a measure for global warming in terms of radiative forcing of a mass unit. In our case, contributing substances are expressed in CO2 equivalents. These are the results for chicken manure as a waste. We note a 47.9 kg CO2 equivalent, while this is 171 for rapeseed. When we consider manure as a good, we note a way higher number of global warming potential. We can see 220 kilograms of CO2 equivalents, while this is only 171 for rapeseed. Finally, this table presents an overview of the results.